session, we'll talk about what's called input, process, and output. So think about math. If you have done math, have you done all functions? So what do we have in a function? You have, let's say if you had f of x equals something like 2x plus 1. So what is considered to be the input and what's considered to be the output, first of all?
The input would be the f of x.
What would be the input? The x would be the input, the x by itself. And the output would be the y. So in case of the y, in this case, it would be what? The f of x itself. That would be the y. Does that make sense? Now, what would be the 2x plus 1 in that problem if we had f of x equals 2x plus 1? Or let me give you another example. Let's say you went to work and you worked for 8 hours and your job pays $10. Okay? So how much will you get at the end of your shift? $80. So what was the input in this?
8 hours.
You inputted 8 hours. What was the output? $80. What was the processing? What happened?
10 hours of work.
Yeah?
8 times 10.
You multiplied, right? You multiplied what?
8 times 10.
8 and 10. That would be the processing. Does that make sense? The input was 8 hours. You multiplied the 8 and the 10. You processed it. That gave you. So that's the 8 times 10 is your processing. And then the output that you got, the $80, that makes it the output. So you have input, process, and output. Does that make sense? So if you had the f of x equals 2x plus 1, you said the x is the input and the f of x is the y, the y is the output. The 2x plus 1, that part that you're doing the calculation, that is what's called the processing. Does that make sense? So this is what we are going to work on. Now, if you work 3 hours, would you get $80? How much would you get? Huh? You would get 30, right? So the input is what? A choice. You can work how many hours you want. That is what? A choice. But the output is dependent on what? On the input. So what do we call the input? Another term in math that's used is what? Independent. You are independent of how many hours you work. You can work 2 hours, your boss will give you $20. You can work 10 hours, your boss will give you $100. So it depends on you how many hours you work if you want to get more money. Does that make sense? So the input is the independent. The output is dependent on whatever you put it in. Does that make sense? So that's what we'll discuss here. Now in this chapter we have designing a program, input, processing, and output that I just mentioned. Displaying output with a print function. So to output something we use a print. Comments. Basically when you document your program you have to use what's called comments. To explain what that program is doing, what that line of statement is doing, and so forth, what that function is doing. Variables is temporary storages where you hold information. Then we have reading input from the keyboard. You ask the user, how old are you? What's your name? We did do that, right? Some basic last class. And then performing calculations. That's what I was talking, like the 2x plus 1 or the 8 times 10 that you just did. More about data output, and then named constants we'll discuss. And then introduction, we don't discuss the last point there. Okay. All right. So programs must be designed before they are written. So the first step in program is designing flowcharts and pseudocode help with this process. So part of your first project is to have some type of flowchart or some type of pseudocode. Pseudocode is basically a fake code. So you kind of write it to say, this is what this program is doing. If this happens, do that, and if this, and so forth, something like that. So it's just a plain English, kind of like fake, but it resembles a code. That's what's called a pseudocode. So the program development cycle is basically, this is a cycle. Anytime you write a program, you design the program, you write the code, you correct the syntax, test the program, and so forth. All right. So you design the program, write the code, correct the syntax, test the program, correct any logical errors. So the purpose of programming logic design is to focus on flowchart and pseudocode and the design is the foundation of a good program. So this is basically the development life cycle. So things that you go through. You design the program, you write the code, correct the syntax, test the executable code, debug it, and then go through it, basically. Okay. So there are 2 steps in designing a program. So understand the tasks that program is to perform, learning what the customers want, determine the steps that must be taken to perform the task is the second point, create an algorithm or a step-by-step direction to solve the problem, and you use flowchart and pseudocode to solve it. So design is the most important part of the program development cycle. So understand the tasks that the program performs, work with the customer to get a sense of what the program is supposed to do, ask questions about the program details, create one or more software requirements. This is what's called requirement and specifications. So whenever you're writing a program, before it used to be the programmer that would meet the client and say, what do you want? Okay, so you collect any requirements they have, specifications, and you write down, you try to program that. Now we have, they created a position in IT called business analyst. So the business analyst is basically in between the programmer and the customer or the client. And then they would gather information, the scope of what this project is about, the requirements, any specification. They write everything they can write, and then they bring that to the programmer, and the programmer will write it. Okay. So, and then the programmer will determine the steps that must be taken to perform the task, basically break down the required task into series of steps. So you create an algorithm or listing logical steps that must be taken. So algorithm is basically a set of well-defined logical steps that must be taken to perform a task. Okay. And the pseudocode, like I said earlier, is basically a fake code. It's an informal language that has no syntax rule. So not meant to be compiled or executed. It's used basically to create a model for a program. So you don't need to worry about syntax errors. You can focus on program design and can be translated directly.
So it's like a rough draft.
Yeah, it's kind of like a rough draft, but it will look like a code, but it's not really a code. You're actually writing like the English part of it. Okay. So this is an example of it. So it's a fake code used as a model for programs, no syntax rule, well-written pseudocode, can be easily translated into actual code. So this is how it looks like. Okay, display, enter the number of hours, input hours. Display, enter the hourly pay rate, input pay rate. Set the gross pay equals hours times pay rate. This would be what? The processing we were just talking about, right? We process that, and then display would be what? The output. So that's how you write when you write a pseudocode. Remember, project 1 asks you basically to define your business, and which we'll go over soon, and then you have to write a pseudocode. So this is whatever you're asking that customer has to be said in details. Whatever variable, which we'll discuss here later, is you have to write that as well. Okay. And the next thing we have is what? What's called flowchart. What is a flowchart?
Step by step.
So what program do we use for a flowchart? We use the flowchart, the Raptor, right? So it's basically a diagram that graphically depicts the steps in a program. So overalls are terminal symbols, parallelograms are input and output symbols, rectangles are processing symbols, symbols are connected by arrows. So this, again, we went over last time, kind of explained to you, and this is just a little explanation of it. And we will see it again today. So it kind of looks like this. So the start and the ending are the same. Okay, so this would be what? The input. The input and the output are the same. The only difference is when you write where the error comes in. The input, the error will come in from this side, and the output, the error would go out from here. Does that make sense? That's how you know within the Raptor. But this would be what? When it's a rectangle like this. This is what's called the assignment. This is the processing. Does that make sense? This would be the processing, and this would be the display. Okay. So typically, a computer performs 3 steps, right? Receive input, perform some process on the input, and then produce the output. So that's why you have input, processing, output, or what's called IPO. Does that make sense? So the input, the number of hours you worked, process is multiplying those two, and the output is after you have multiplied what you get. Okay, so this is another way to write it as a chart. So you have the hours worked or the pay rate, you take it to the processing, you multiply that, and then the output is what you get. So this is a chart that you can write called the IPO chart. And then display and output functions using the print function. Then we have what's called a function, which is a piece pre-written code that performs an operation, right? So like f of x equals 2x plus 1, it's already pre-written. There are multiple functions, okay? So print function displays an output on the screen, argument, data given to a function. Example is data that is printed to screen. Statements in a program execute in the order that they appear, so from the bottom to the top. So we have output, input, and variable. So programmers can define variable names following certain rules. So what do we say variable is, first of all?
It's a placeholder for another number, letter.
So variable is a temporary storage place, right? So it will hold some information for you. And we'll discuss something called data types later. So it's holding some information for you. And it can what? What do we know the word variable? What does it mean? It changes. So it can hold. Like let's say you stored $10 now to hold it for you. After a few steps, you can say, you know what? Hold 15 for me now. Does that make sense? And the way you name it, so it must be one word, no spaces. Generally, punctuation characters are avoided. Generally, the first character cannot be a number. Name a variable something that indicates that may be stored in it. So this is an example of way to name it. So a camel case is a popular naming convention. So variable name that represents a value stored in the computer memory used to access and manipulate data stored in the memory. So a variable references the value it represents. So assignment statement used to create variable and make it reference data. So the equal sign is what's called an assignment. So here you have an example, age equals 29. Okay, the assignment operator is the equal sign. So in an assignment, the variables receiving the value must be on the left side. Variable can be passed as an argument to a function. Variable name should not be enclosed in quote marks. So you can only use a variable if a value is assigned to it. So the rules again, rule for naming variables in Python cannot be a Python keyword. Variable name cannot contain spaces. First character must be a letter or underscore. After first character may use letters, digits, or underscores. Variable names are case sensitive and should reflect its use, meaning that if that variable is holding the cost of, let's say, chicken, don't name that variable to be banana. Does that make sense? It has to reflect what it's trying to achieve. So some expressions stored in variables, and then the math operators. So to calculate anything, we use math operators. So a plus sign means addition, subtraction sign. Most of these you should know except the mod or the module. Module is basically used as a remainder. So meaning if you say 5 mod 2, you're saying what's the remainder in this? How many times does 5 go into? 2? 2 times. What's the remainder? 1. The answer would be 1. Does that make sense? So the mod is used for 1. And the Python uses also percentage instead of the mod. Other languages also use the same thing, use percentage. Okay, string and string literals. So a string is a sequence of characters that is used as data. So when we say hello world, that is held in a string. So remember last time we had to ask, what is your name? We put that in quotation. So that's a string. So a string literal, a string that appears in actual code of program, so must be enclosed with a single or double quotation. So a string literal can be enclosed in triple quotes. Okay, so enclosed string can be contain both single and double quotes and have multiple lines. Then comments is a way to basically document your program. Notes of explanation within a program ignored by Python interpreter, intended for a person reading a program's code, begin with the pound symbol. So end-line comment appears at the end of a line of code, typically explaining the purpose of that line. Then you have external documenting a program. External documentation describes aspects of the program for the user, sometimes written by a technical writer. Internal documentation explains how parts of the program works for the programmer, also known as commenting. Comments are often distinguished within the slashes, but in this case we use pound or a hash. Again, when you're doing your projects 2, 3, and 4 all the way to 7, some of you might lose points because you didn't do any programming. Okay, so make sure that that doesn't happen. Okay. So Python allows one to display multiple items within a single call to print. And I have shown you that last time, right? Was it this class or the C++ class? I think it was C++. So I will show you actually today. So Python allows one to display multiple lines in a print. So items separated by commas when passed as arguments. Arguments displayed in the order they are passed to a function. Items are automatically separated by space when displayed on the screen. Variable reassignment. Variables can reference different values while program is running. So you have what's called garbage collection, removal of values that are no longer referenced by variables. And the Python interpreter deals with that. A variable can refer to an item of any type. Variable that has been assigned to one type can be reassigned to another type. Then numeric data types, literals, and the str data type. So data types categorize values in memory. So we have int for an integer, float for real number, a string used for storing strings. We have numeric literals, number written in a program, no decimal point considered in otherwise considered a float. Some operations behave differently depending on the data type. What is a data type? So we said a variable is what? It's a placeholder, right? It's a temporary storage that you're storing something in. Now, the data type is what kind of information are you trying to hold in this variable? Now, for example, let's say you have water, okay? Can I put that water in a plastic, let's say that garbage plastic that has holes in it? Can I put water in there and carry it around? No. Can I put knives in that plastic? Huh? Can I put knives in there? No, it will make holes and it will drop. But how about if I had a bunch of mangoes or something? I can drop it in there and I can carry it. Does that make sense? But the water, I can put it in that container, right? That bin, I can put water in there and I carry it around. It doesn't spill. So data type is the type of data that you're trying to put it in. Okay? So if I had a box here and I had a plastic bag and I had a container and then I had, let's say, knives, I had mango and I had water. Okay? Where can I put the water? Where can I put the knives? And where can I put in the mangoes? If I had a box, normal box, like, you know, like we have here with books and stuff, or a plastic bag or that container. The knives in the box.
Plastic bag with the mango.
Huh?
Plastic bag and the mango.
Okay, the mangoes will go to the plastic bag. The water will go in the container. Does that make sense? So this was called data type. And all of them are variables. Does that make sense? The plastic is the variable. Okay? The type of information we're trying to hold. So data type is the type of information. Basically, say it backwards. Data type is type of data that you're trying to hold. Does that make sense? So if, let's say, I'm trying to hold this variable, my name, okay? That would be what? A string or an integer? Can we use the name, how old are you, and what's your name in the last?
Yes.
Okay. Can I use a string to hold my age?
No.
It has to be what? If I'm trying to hold my name, my age. My age would be what? Integer. My name would be? Does that make sense? So this is what's called a data type. The type of data you're trying to hold and what variable. So if I'm trying to hold my age, I will say int, which is the type of data I'm trying to hold, and then the name of it. I will say int and then age. Does that make sense? So I'm saying it's good. The type of data I'm trying to hold is an integer, and I need the variable name to be age. And then I will say equal to 90 years old. Healthy 90 years old. Does that make sense? Then in the case of the name, I will say string. Again, I'm saying this is the type of data I'm trying to hold. The string means something in quotation. Then I'll say name or first name or last name. Does that make sense? And then I'll say equal to whatever the name is. Does that make sense? Okay, so data type basically means the type of data you're trying to hold, and then the variable is where you save that information. Okay. Any question on data type and variable? And you will see it used soon. I'll show you. Okay. And here is showing you how you save. A variable in Python can refer to the items of any type. So most programs need to read input from the user. So built-in input function reads input from the keyboard, returns the variable as a string. So format would be variable input prompt. Did we do this? So we said something like name equals input and then what's your name, right? Something like that. So prompt is typically a string instruction user to enter a value, doesn't automatically display a space after the prompt. So input function always returns a string. So built-in functions convert between data types. Okay. So built-in function convert between data types. Int item converts the item to an int. Float item converts item to a float. So nested function call, general format will be function and then the function argument. Value return function 2 is passed to function 1. So type conversion only works if the item is valid and so. So math expressions perform calculations and gives values. Math operator tool for performing calculation operations. Values surrounding operator variable can be used as operands. So resulting value typically assigned to a variable. Two types of division. Operator performs floating point division, and 2// operator performs integer division. Okay. So positive results truncated, negative rounded away from 0. So Python operator precedence. So it follows the order of operation. Multiplication and division, we know this. And the remainder is a percentage, which is what's called what? What do we call this? Module. Very good. And addition and subtraction. So we have higher precedence performed first. So some precedence operators execute from left to right. Exponents raise a number to a power. And then the remainder operator we just discussed, 5% to. So typically used to convert times and distances and to detect odd or even numbers. Converting math formulas to programming statements. So operator required for any mathematical operation. So when converting mathematical expressions to programming statements, you may need to add multiplication operators. You may need to insert parentheses, then mixed type expression, data type conversion. So 2 int values result is an int. 2 float values result is a float. Int and a float, int temporarily converted to a float. Result of the operation is a float. Again, some of these, for you to do it, you kind of have to play with it. I'll show you an example. So types of conversion of float to an int causes truncation of a fractional part. So breaking longer statements into multiple lines. So you can do this. It's fine. Long statements cannot be viewed on screen without scrolling and cannot be printed without cutting off. So multi-line continuation character, this slash allows to break the statement into multiple lines. And basically I put that slash to say, you know what, I need another line. So any part of the statement that is enclosed in parentheses can be broken without the line continuation character. So you can do this. Again, when you see some of these examples, try to run it on your in your computer and test it and see. So print function displays a line of output, new line character at the end of printed data. So special arguments and delimiter causes a print to replace the delimiter and end of data instead of new line character. So print function uses a space as item separator. So a special argument except delimiter causes a print to use delimiter as item separator. So some more special characters. /n, that's one widely used, or /tab. So /n is a new line, horizontal tab, treated as commands embedded in a string. When a plus operator used on 2 strings, it performs string concatenation, meaning like if you have to put a string in hello and then another string in world, and then you use the plus sign, that's called concatenation. You're putting hello and world together. So when you print it, you will print hello world. Formatting numbers. So you have some built-in functions you can use. 2 arguments, numeric value to be formatted, format specifier, okay, returns a string containing format and number. Format specifier typically includes precision and data type. And it can be used to indicate scientific notation, comma separators, and the minimum field width used to display the value. And you will need to use it in one of your assignments, I think 3 or 4, to make sure you're using the format. The % symbol can be used in the format string or format function to format number as percentage. So to format integer using format function, use D as the type of designator. Do not specify precision. So you can still use format function to set field width, comma separator. and then some magic numbers. The magic number is unexplained numeric value that appears in a program's code. Example, amount equals balance times that. So what's the value? 0.069 is an interest rate. Fee percentage, only the person who wrote the code knows for sure. So you have to make sure something like this, you define it and hold it with a variable. So in case you have to change it, you only change to that variable that you're holding. So the problem with these numbers, it can be difficult to determine the purpose of the number. If the magic number is used in multiple places in the program, it can take a lot of effort to change the number. In each location, should the need arise. You take the risk of making a mistake each time you type a magic number. Okay, so that basically means that you're putting a number in the middle of the program. Don't hold just a number straight because nobody knows. Hold everything in a variable before the program starts. So it's better to use what's called named constants. So you hold it in a variable like this. This is called a named constant. Then now you can say amount equals balance times interest rate. Okay, so it's easier. If you had to change the interest rate, then you can just change it here rather than going through the code and find it. Okay. So the advantage for that is named constants make a code self-explanatory and self-documenting. So named constants make code easier to maintain. Change the value assigned to the constant and the new values text effect everywhere a constant is used. So named constants help prevent typographical errors that are common when using magic numbers. So designing the first program. So looking at this program, so let's say here it says calculate the average for any player. So again, try to understand this slide and the next slide, and anytime you get a problem, so the approach will be different, the same way. Okay, the problem will be different, but the approach will be the same way when you get a problem. So here it says calculating the batting average for any player. So the first thing is that you need to know is what? The batting average is what? Number of hits divided by times at bat, right? So this will be the assignment or the calculation that you would do. All right. So to determine what is required for each phase of the program, what must be read as an input? What will be done with the input? What will be the output? Remember, think about the example that we just talked about earlier, that you go to work and you work 3 hours. Okay. So what would be the input? What would be the assignment or the calculation that you would do? What would be the output?
But you asking her?
Hits.
Hmm?
Would the input be the hits?
Okay.
It could be times the bat. Times the bat is the input. The hits is the output.
And the output will be the batting average.
Yeah.
The calculation, right? So the input received will be two things, right? The number of hits and
Number of times at bat.
so both of them would be the input. And then the process would be what? Calculating the batting average, that's given to you, right? And then divide the number of hits by the number of times at bat. So the output would be what? The player's batting average. Okay. And then an example of that. Okay, enter the player's number of hits, enter the player's number of bat, and then you enter it, and then you get the calculation for that. And what you see here is basically a pseudocode. Okay. So declare display input. This is an example of a pseudocode. So as you're doing your first program and where you're writing that Microsoft Word document, when you're asked to write a pseudocode, this is what you're doing. And when you write a pseudocode, remember pseudocode is what? It's a fake code, right? And the fake code, you don't leave out anything. The fake code, what? You don't leave out anything. You write everything you need to write. Declare an integer, declare real, declare, because the program doesn't know. Any variable that you're going to declare, that you're going to use, you have to declare it in the beginning. Any input, any output. Okay? All the pseudocode, you don't leave out anything. Does that make sense? You don't leave out anything. Let's look at the actual requirement of the first programming project 1, right? And under unit 2. Okay? So let's look at it so you have an idea. So in this it says what? You have just opened a business with your own food truck. Now, to keep things simple, you are planning on selling just 5 items. You're going to design the logic for a program using a Raptor Flowchart to display customers' receipt showing each item ordered. Okay, so the quantity, the price per item, the amount ordered for each item with a total at the end. Food ordered from a food truck is taxable, so you should also then calculate 6% sales tax, display it, and then calculate and display the total including tax. Also, since your business is quite new, you're not going to accept credit cards, meaning that everything you're accepting is cash, but so you only accept cash. So your receipt so the receipt should also show the amount tendered by the customer and the amount change due. So for this project, what do I say? So I don't need a Raptor for this. I don't need Python for this. You're just creating what? A Word document with the following sections. So these are the sections you have to do. In the first section, you're doing what? So you're describing your business and you give it a name. Okay? Don't say M&M sells chicken. No. Explain everything about the business. Then after that, give it a name. Okay? Bullet points or table of lists to list the 5 items you will sell with the price of each. So you will sell a bullet point with what? The items you sell. What's an example of that?
French fries.
Huh?
This is an example.
So French fries, what?
$2.99.
French fries equals $2.99. That will be an example of that bullet points, right? And then the next one says what? Pseudocode to list the constants needed by your program, the values assigned to each. So it says, look at the chapter 2. That's the one we just went over on named constants, and be sure to use the programmer's convention for named constants. It's giving you an example here. Okay.
Ain't that pretty much the same as the bullet points?
It would be similar here, but it will just, this one will be similar to this one, but here it's not just the basics of this, because you're also doing what? The whole pseudocode. Does that make sense? Everything that we
The
have.
only thing you change is where it says small pizzas, correct?
Yeah, so because in this real constant doesn't exist here. Does that make sense? And then the next thing is what? Variable declaration on your input items. Every input item, anything that you are inputting has to be what? Also declared here. Has lots of examples. There are some examples that we have just seen. An example would be how many of each item in the customer is ordering. Okay?
So like small pieces is like the number of pieces you're gonna get.
The number, but you're using the variable. So here, again, this is variable declaration. So any variable you know you will use in the program, you're declaring it here. So choose appropriate variable type for these variables since they will not have fractional parts. So an example of that would be declare integer, some small pieces. All the declarations that you will do it here. Okay, so any input, anything that you'll be asking to that customer, you list it here. And it says list every variable that you will need to output. So here there was all the input, now will be what? You will list all the outputs, anything you will print to the screen. So all the outputs, all the displays will happen. The variables as well as what you're displaying, right? That's not already input. So one example of this is the amount the customer owes for a particular item, which will be calculated. So that, for example, you might call the amount owed for a small business. So this is an example, cost of small pieces. Notice the camel case. I'll show you one. Last, give an example of a customer's receipt. So be sure to include the name of your business. Any of you that didn't see a receipt? Any of you that have not seen a receipt? Okay, so you all know how a receipt looks like, right? What should a receipt have? Huh? So what, you can make your own business, but what should a receipt have? Name, address, phone number. Yeah, so you don't leave out anything. And then after that, you would list all the items, quantity, description of what you bought, the total, how much you paid, the tax, everything is contained in that receipt. So you're providing an example of that. The cash that was tendered and so forth. Okay?
Sometimes has a return policy.
At the bottom, you have the thank you and whatever you want to add to it. Okay? So basically a normal receipt. Now let's do a sample of that. Okay? Now, if I was trying to do, I'll do the basics so that you can kind of like mimic it when you're doing for your project. So using the Raptor and the Python, I'll show you. Now let's say if I am putting out an output of the receipt, what should I use here? I would use an output to print what? Something like a receipt, right? Mm-hmm. So first it's asking me to save, so let's save it on the desktop and give it what? Test or something like that. Okay, so the output would be what? M&M restaurant or something. And then another line for the address, another line for, and so forth. Okay. Then after that, what do I do? I'm trying to sell, let's say, chicken and banana. So if I'm trying to sell chicken and banana, what's the first thing that I should do? What do you say? Define it. So define would be what? What was the term that we have seen here? Declare. So defining or declaring mean the same thing, okay? So basically, so we need to what? Define it. So we will use the assignment to define it. So we drag that here, and then here's where we define. So if I'm selling banana, I will set the banana and then how much I'm selling to that banana. How much am I selling the banana? Yeah? $2.99 you said? Okay, $2.99. So we said, so we're saying I'm assigning the banana to be $2.99. Okay, another assignment would be what? Chicken? And then $1.99. I mean, at the rate of they're producing chicken, before you know it, the fruits will be more expensive then. Right? So this is an example of we're declaring, right? Two variables. And we are assigning them. Now, after we declare and we assign, now we have to ask what? We have to ask a question, the customer, right? Mm-hmm. So which one do we use, output or input? Input, because we are trying to ask a question. So we drag that here and drop it here. So we click on that and we say what? We put a quotation and say, how many bananas do you want? Okay. Then here, now we are asking the question what? How many bananas do you want? So what should we name our variable? When I say how many bananas do you want? Number of bananas or quantity? Does that make sense? It has to make sense. So we can say number of banana, okay, or quantity of banana. That's fine either. Okay. So this asks how many bananas. Then we need another one, right? For the chicken. We put a quotation. Remember, it's a string. We are putting a quotation in. How many chicken do you want? And then here will be what? Number of chicken. That makes sense? Now we ask the question. Now we know the cost of the banana and the chicken. Now we ask the question. We're trying to get the quantity and the number of items from the user. Now what do we do after we get that?
They answer how many they want.
Yeah, by asking the question, we're getting the information from it, right?
A small or big bananas.
Do I have a small banana or big banana here? I just have a banana that's just $2.99. So what do I do after I have declared it? I've asked the question to collect the data. So what do I do now? Huh? Calculate. So now we have to calculate. So which one do we use to calculate? The input, we are asking a question. The assignment, we assigned it this. We use the same one, the assignment, to calculate. Okay? So how do we assign? So now if I need to know the cost of banana, I can declare a variable here, call it cost of banana. Does that make sense? Then here, the cost of banana of whatever this person bought would be what? How do we process this? Huh? What would it be? Very good. Banana. What's your name? Cameron. Very good. Banana times what? Cost of banana is what I'm trying to set. Banana times what? Very good. The number of banana is already selected. I can just press enter and it will give it to me. You see that? Because it's highlighted for you. So it says banana times number of bananas. So that calculates that for me. What else do I need to calculate? Chicken what? I have chicken. What are you trying to say? Cost of chicken. Very good. So we will call it what? Cost of chicken. Again, these are variables I am declaring. Remember, when you're writing your Word document, everything I'm declaring here, similar to you're declaring everything you're selling. Your inputs, your outputs. Okay? So that's how you're declaring there as well. So cost of chicken would be what? How do we calculate that? Huh? Say it again. Chicken. So it would be chicken times cost of chicken, right? We have cost of, is it cost of chicken? Number of chicken, very good. Okay, and we can highlight it and then just press enter. So chicken times number of chicken. I'm saying multiply this one times this one to give me the cost of that. Does that make sense? So I'm multiplying the cost of chicken times the number of chicken. All right, that will do the calculation for me. Now I declared the variables and how much is, I assigned the value. Then I asked the customer what they want, how many of them they want. Now I set up the calculation. Now what do I need to do after that? Huh? I can't hear you. Who's talking? No, before I get to, we can do so first we did the input and we processed it. So think of it like that. We input it, we processed it, then what happens? So it will be input, process, and output. Okay, so now we take this and drag it here. Okay, so remember it's always input, process, output here, right? So here we will say what? So this is the output that we are trying to show the user. So what do we show the user? How should the receipt look like? Basically, the output that they will see.
The name of the business?
No, we're just talking about the order here. The name of the business, we already printed that. The quantity, right? So what do we call that? Number of
bananas.
So number of banana. Oops. So this would be number of banana. And then I will say plus. Why plus? So that I can concatenate. Remember, the plus sign is used to concatenate, to put two things next to each other. So the first thing I'm putting in is the number of banana. That's how many they bought. And then this was banana, right? To show that that's what they bought. And then we can say plus, and then put a quotation and show each. Each one was what? This was banana, right? To show the cost of the banana, and then we say plus sign to show the total cost of that. Okay? We show the banana, and then we can say costs or something like that. And then put a dollar sign in there. Why I put a dollar sign in there? So that the dollar sign shows up with the cost, total cost. So this would be costs plus dollar sign, and then this would be cost of, this was cost of banana, right? You see that? So this would give me a receipt that has the quantity, what I bought, how much each one costs, and the total cost for that. So that was for the chicken. I need another one like this. I can right click on this and then say copy, and then it's the same place, and then just say paste. But now it's the same thing. I need to modify this. Instead of number of banana, this would be what? Number of chicken. right? And then instead of banana, this will be what? Chicken. I'm just showing you because you're doing like 5 of these. You can basically do copy and paste after you have done one of them right. Okay, chicken, and then cost, instead of cost of banana, this would be what? Cost of chicken. And again, you have to make sure that you write these variables in a notepad so that you don't misspell anything. Does that make sense? We can run this to have, so that we have an idea of what we are going to get. You know, sometimes you don't want to write a huge program and you make a mistake and you have no idea where you made the mistake. So we write, you know, few lines of code and then we run it just to have an idea. So here we run it. It says, how many bananas do you want? Okay, so here I can put 2 bananas, and then it will ask the question, how many chicken do you want? I need 8 chicken, since it's cheaper than the banana, right? So here it says, M&M restaurant, you bought 2 banana, each at that. See, it's not formatted yet. I need some space. Costs, I need some space, and then it shows you, you multiply the 2 and that to give me that, and then 8 chicken, each at that. So now you can go back and add spaces, format it however you want. Does that make sense? And then add your thank you and all that. Okay? So the first issue we see is what? We need some space between the name and I'm just putting a name in here. I already explained to you what you need on a receipt, right? Then we need some space. And then after that, when we were putting the output here, we needed some space. I think after each, we need a space here, some extra space here, number of bananas. What else? And then here the same thing, we needed some space after the each, I believe. And then we also needed some space after the costs, something like that. And then here, I think we also needed, you can even put another output just to create some space if you want. You understand? Like I can put a quotation in and then put some extra space in and then put a quotation just to end like that. Does that make sense? Just to make it better. You can clean it up. And then I can put another output here at the bottom, right? To say, you know, put some space in and then say thank you and come again, right? All this, again, I'm just showing you the outputs to clean it up more. All right, so if we print it again, it will ask you, did I run it? How many? 5. How many of that? 2. Then it will do the calculation, and then it will show you. See that M&M? I have space now, spaced out a little bit. Does that make sense? You can space it out as much as you need. Another thing that we need is, when you ask a question, how many chicken do you want? Okay, here it says what? How many bananas do you need, right? I can concatenate and show the cost so the customer knows how much these things cost. So if I say how many bananas do you need, I can concatenate and say each at, right? And then put a dollar sign, put the quotation, and then put a plus sign, and then just type banana. Okay? So now when I run it, when it asks how many bananas do you want, each at that, it's telling me now how much it costs. So the customer knows, rather than just saying how many chicken do you need, how many bananas do you need. It shows the cost. The customer say, oh, I see the cost now. This is how much I need. Does that make sense? So you need to do that for each item. Like here, it says how many chicken do you want. It doesn't make sense. So you make sure you change that so that you will do it the same way as the others. Okay? So I just defined a couple of variables. What are some other variables I can declare that I can add in there? Huh? Tax. See the problem, the project itself asking you to use a tax. So we can assign a tax as another variable. And then all other variables that you need to declare it here. What else? Another thing that you can calculate is what? Let's say total cost, right? Like you can put a total cost here. What would be the total cost? Here you can say total cost, right? And then total cost would be what? Huh? Very good. So cost of banana plus cost of chicken. And if you had a bunch of costs in your case, you will have at least 5. So you're calculating all that. Then after you calculate all that, what do you need to do?
Put the sale tax.
You need to put the output in. Of course, you need to do the sales tax. Yeah, I'm just showing you a basic. So here, then we will say what? Total cost for this.
Transaction.
Yeah, you can say that. I'll just say total cost, right? And then maybe you want to add total cost like that, and then put a $sign in, right? And then here would be what? The variable, which is total cost, right? Which is the bottom one. You can type it out exactly, make sure they match. So now if we run it, okay, 2 of these, 3 of that, it will show you, and then it will show you the total cost, the addition of these 2. You see that? Mm-hmm. Then you will have one that will, you have a total cost, you will have a total cost of, or the total amount of tax. So you have a subtotal, this would technically be the subtotal, then you have tax amount, then after that it would be what? The grand total, however you want to call it, or just total, okay? So you need to think about it as you're writing that Microsoft Word, that you make sure that you have everything in there. Now the other thing we discussed in this presentation was what? So we talked about variables. The data types, basically whether this is decimal, integer. So this was like an integer because we were putting in, and this was decimal, right? We were putting in a float. But the other thing we discussed was the commenting. So the commenting is basically, what's this project about? So you right-click it and you click on comment. Then here, this is where you write what this project is about. What do we say? Demonstration, demo for flowchart, and then Dr. Ali. Date would be what's today?
27.
2020. Say author. Okay. So whatever you're adding, all the details, you put it in there. So this would be sample commenting. And then this one here, you can say, again, any calculations you have done, you explain it. So let's say something like this. You write a comment, and then you say, subtotal for transaction. Okay, something like that. You put a comment in. Does that make sense? So this is what's called documenting your code. So you make sure everything is documented correctly. Does that make sense? So this is how you use Raptor. So of course you will have 5 of them for the items that you're setting and any other variable that you would use. So any question on the flowchart? Say it again.
Get like spacing between your you just use new line.
Yeah, you can use a new line. Okay. Now let's look at the same thing if we had to do this in what do you call it? In Rebel. Okay. So when we declare the same way. So here we were setting what? Banana. Let's say it was $1.99 or $2.99. What do you guys say? Banana, chicken. Oops. Chicken, $2.99. And then after that, we were asking a question, right? What do we say? Number of chicken or number of banana? Number of banana. And then here, we can say integer or float or data type because number of banana is an integer, so we can say integer open parentheses. When you ask a question, it's what? An input. Okay, so we'll say, how many chicken do you want? Okay. Okay. Next, number of chicken. Then we do the same thing. How many? Actually, the first one should be banana, right? You guys are not paying attention. Are you with me?
I'm in banana.
You're kind of going a little fast.
Slow me down.
Slow down.
Okay. So the first one, I'm asking how many bananas do you want? Second one, I'm asking the question, how many chicken do you want, right? And we can take the same approach as we took the other time, right? So in the beginning, we can say what? Print M&M restaurant or something, right? And then you can print the address, you can print the phone, and so forth. So that was basically the output, and then we're doing the input. We did our declaration. As much as you can declare, you do your declaration there, and then you're taking the order here, all your 5 items. Then after we took the 5 orders, what do we do in the Raptor? We declared it, and then after that we were asking the question. We asked the question, and then after that we did what? We did the processing, right? The processing was what? Cost of this equals that, and so forth. So this would be cost of banana equals what? Banana times number of banana. Again, make sure you don't misspell anything, okay, that you're paying. Use Notepad so that you just copy and paste the names that you use. And then the next one was what? Cost of chicken, right? Equals chicken times number of chicken. Okay, this has to match this. See how it's highlighted? As soon as I highlight, it looks for it. It knows it exists. Okay, number of banana, it knows where to match. When I highlight banana, it will know that it highlights where banana I declared. They have to match. If when you highlight and it doesn't highlight the other variable, you know you misspelled something. Very important. Then after we calculated, what do you call the number of banana and the number of chicken? After that, we did what? Yeah, we did the output, right? So the output was what? When we output, we use what? Print, right? So the print, the first thing we had to print was what? The quantity, right? Which was number of banana. And then after that was what? What do we call it? Banana, right? Huh? So we're dealing different language here.
Oh.
Right? And then it would be what? But technically you can use the last plus as well. And then after that, after banana was cost of what? What do we print after that? Where was it? So we had the each at, right? So this was each at, right? So each at would be what? This would be banana. And then this was what? Costs. $, and then this was, what do we call this? Cost of banana. You see that? We can copy this and paste it, right? And then just change what we need. Instead of number of banana, this would be what? Number of chicken. And then instead of banana here, this would be chicken. Each at, instead of banana, this would be what? Chicken. The ones that are not in quotation, you make sure that you match the ones that are not in quotation here, the variables you have declared. The quotation is just a string. Okay, instead of cost of banana, this would be cost of chicken. Then after we calculated the cost for each, then what do we do after that? Then we calculated what? Total cost, right? So we do the total cost. Total cost was what? Or we can say subtotal if you want. So subtotal was what? What's the subtotal?
The quantity of banana
But do we call it quantity?
or
Huh?
number of.
Subtotal would be what? Cost of, very good. So it would be cost of banana, which is this variable right here, then plus cost of chicken. Okay? So that just gives us a calculation of the subtotal. So after we calculate the subtotal, then we need what? Very good. So we need to print this. So print, this would be subtotal. And then subtotal, you can actually leave some space out, so it's formatted right. You put the dollar sign there, and then here we put subtotal. And after that, after you show them the subtotal, then what do we need to print? Huh? Thank you. Come again, right? Something like that. And then the other thing that we left out is what? Documentation, right? So we put a pound for documentation for Python. So this would be program demo for restaurant order, then author Ali 8 January 27, you said, and so forth. And then special functions, any other details, you can document like that. For calculation of subtotal. Like any other thing that you want to say, right? So the more you document, the better. Make sure you document it. Then after that, we run it. So here it says, it shows you the name, and then here it says, how many banana do you want? 2 banana. How many chicken do you want? 3 chicken. And then it shows you 2 banana, each of that costs that, 3 chicken, each of that costs that, subtotal. You see that? Thank you, come again. And of course, you would do multiple of these that you're formatting. Okay? So again, you won't have to do Python assignments until you get to, is it project 4, I believe? Is it 5 through 7? And then 2, 3, and 4, 2, 3, and 4 you're doing Raptor, and then 5, 6, and 7 you're doing Python, and then the first one you're doing Microsoft Word. Okay, but again, it's good to know as you're writing project 2, I mean, that you actually try to write it the Raptor as well as the other, so that you're familiar, you're going back and forth, rather than you just concentrating on Raptor, and then you come back when it's time for you to do Python. So try to do both of them at the same time. Okay? Any question? Okay. Good.